Hello, everyone, and welcome. Thank you for joining us for today's session. My name is Firas, and I'm the event planner for Microsoft Reactor in Redmond. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our presenters and audience. We encourage engagement in the chat, but please be mindful of your commentary and please remain professional and on topic. This session is recorded. It will be available through the Microsoft Reactor YouTube channel in 24 to 48 hours. I'll be sharing the link to our YouTube channel in the chat. I'll also be sharing the Reactor Meetup page link. In addition to that, I'll also share the link to our survey so you can let us know how this event went. Which brings us to our session today. This session will run for approximately an hour with time for questions throughout. Our speaker for today is Sam Wronski. He's a regional cloud advocate. I'm now going to pass this along to Sam.
All right, awesome. Thank you so much. And hello, everybody. I am Sam Wronski. I'm a regional cloud advocate here at Microsoft. My job is to help empower all of you to build awesome things with Microsoft technology. So what we're looking at today is OpenAPI and Swagger. So these are sort of foundational components when we're talking about APIs, when we're talking about how we're actually going to communicate with all of these services that we're building. So OpenAPI is sort of the specification that talks about or describes the schema of what we're using, and Swagger is typically the tool set that kind of goes on top. You might see these interchanged between one and another, but today we're hopefully going to dive into this and kind of show you how you can use Swagger in your own applications and how you can take advantage of Swagger from other applications, whether that's other teams at your company that have built some other application, or just an open project that has published an API spec with Swagger, and you want to interact with that through your own application. So hopefully we're going to kind of cover all of that. We're going to be looking at this from the lens of a .NET developer. But OpenAPI is just a documentation for APIs. That's not language dependent. So this is something that will work regardless of the language that you're developing in, whether that's Java or Go or C#. It should all work. Some things might be slightly different, configuration and things, but for the most part, all of this should kind of apply across languages. So that's sort of what we're going to get started with. I have some docs up, but we're mostly just going to be kind of coding this from scratch. Because I think that'll be more fun. I don't think there's anything we need to talk about here, so let's just do that. So I've created this empty project just to kind of get started. So we're going to create a new web API. So .NET new web API, and let's just call this our weather service. This is just going to be a service that returns the weather. That's the default controller. So this way, we're not going to code a controller. That's not really the point here. Instead, we're going to take advantage of some of the cool things that we already got as part of creating this. So if I go and look at what got created when I did this, we got a few different things. First, we got a controller, which looks like this. So there's nothing here describing the API or doing anything like that. This is just how we interact with it. This is all of that. We're not generating a Swagger spec. That's not happening here. It's just this. So we have this one HTTP get thing, get method that is going to go out and get the weather forecast. So it's going to go out, retrieve a weather forecast, and bring it back for us. And it's just generating a random set of results from that. The actual content of the API doesn't particularly matter. The interesting thing is the return type, which is defined here. So this is a type. It has a type definition. It's not just a string. This is a weather forecast enumerable set. So we're going to return some set of enumerable objects here and then be able to do something with this. So this is the one method that our API currently has. So what we're going to do is create something that can allow us to interact with this and use this. And so that's already done. That's the cool thing with all of this. We go into our program. You'll see there's a few lines here that are kind of helping us out. First, there's add Swagger gen, which is going to automatically add a Swagger generation service to our application. The other two bits down here are saying if we're in a development application, if this is not a production application, we're going to enable Swagger and we're going to enable the Swagger UI. It's going to publish two different things. It's going to publish a swagger.json file that we can then access and use in different places. And it's going to publish a Swagger UI that we can also access and directly invoke our API from. So we don't need a fancy like Postman or Nightingale, whichever one you prefer. We don't need either of those. Instead, we can just run this. So let's do that. Let's do .NET run and run our weather service. And this should create a service. Here we go. And so that's all not what I want. But if we go here and go to this point, we can just type in Swagger. And this will take us to the Swagger index file. And this is our API. This is our GET request. And here's what it does. So we have everything that's here. You can see that it's going to return some set of random values. In this case, it's just figuring that out. I didn't define this. This is automatically generated for me. So my API is already documented. It's going to show you, here's the return type, here's the schema that it's going to look like. If you're curious about what the types actually are, what are those type definitions, that's also present here. So you can go and look at that. It's going to have a date, a temperature in Celsius and in Fahrenheit, and a summary. And you can use that to kind of determine what's going on. So then we can also try it out. So let's actually go and send the request to this. If I click try it out and click execute, we just sent a curl request to our API endpoint, hit that endpoint, and got back a response with a whole bunch of data in it. And so we've just invoked our own API from this web page that we generated for ourselves. But that's not all. We've also gotten this really fancy, if I go to, I always forget where this is, but I think it's V1. Oh. Let me go and look because I always forget where this is located. Well, this will be easier. Let's go in here and go and figure this out. So at swagger/v1/swagger. Okay, so I forgot a little bit. Let's do swagger.json. And there's our file. So this is the definition of that API that we just invoked. It's going to tell us what is the service that we're invoking. We're invoking the weather service. What version is it? So we know the versioning of the API. It's also going to have this list of paths that are going to define what that thing does. So we have this set of responses for potential responses. If there's custom things that you can return, like what does a 404 mean in your API? What does a 201 mean, etc. You can define all of those and actually have some documentation here so that it's more clear what should be expected to come back from your API. And then we also have the definition for our types, which are down here as listed as components. So we have a schema called the weather forecast, which is the type that we're returning. And then that's all defined so that everything is kind of concrete. The reason you do this is because you have data contracts. When we're talking about building a series of services, when we're building a large application across multiple different organizations or people or groups, the boundary there that defines how these services communicate with one another is your APIs. It's your API contracts. And this gives you a way to concretely say, here is my contract. I'm going to align with this. So as long as this doesn't change, everybody up and downstream of you should still work. So as long as you don't change this API schema, anybody that's depending on your service should be able to continue using it. And so this is sort of a reliable way to kind of make sure that, one, you're not introducing any other changes, but two, also making sure that you're actually maintaining something in a way that is consistent with what everybody else is expecting, because you're typically not building a service that nobody else is calling. That kind of defeats the purpose. You typically want something that people can invoke, that interact with in some way. This gives you that method. So now that we have all of this, let's go even further. Let's start actually interacting with this and adding even more. So we've gone and defined all of this, but this is just the defaults. This is what we got for free. So let's add some extra documentation here and talk a little bit about like, what does this service do? So let's add a summary. And I forget how to use these, but there we go. We do this. We now have a summary documentation, and we can actually add additional comments here. I'm pretty sure I'm using this correctly. So let me just go and double check. This is all in our documentation, but this is typically something that I use when I'm creating a project and then do not reuse, just because you've already done it. So you can just go and copy that implementation instead of looking back at the documentation. So we want to describe this. So if I scroll all the way down, here we go. We can define a summary. It's actually going to tell a little bit more about what this API does. So let's go and do that. Turns or calculates the expected weather forecast for the user. Cool. So that isn't necessarily what this does, because this is just the sample API. This is just us working on that. But we can actually add some documentation here and think of this as a contract that you can give to other teams, that you can pass along to other engineers, other developers that might want to invoke your service, that might want to interact with it. I've just added this into my code. But if I go and rerun my service now, that same comment is going to end up in my Swagger spec. So OpenAPI, or the definition that I've created, is now going to have that in there as well, which means that if I go and reopen this, let's go, here we go. You can look at our weather forecast, and it's not there. Why not? What have I done? I'm not entirely sure. Have I? I'm not entirely sure why that's not doing what I expect it to. So that's interesting. Maybe less of a good demo when that happens, but that's okay. We're going to rerun that and just see if I missed something. If not, this is not a big concern here. But it was one of the cool things I was going to call out. Well, no idea. So I don't know why that's happening, but it doesn't really matter. We're just going to move on. What this does is allows you to actually pull in some of those documentation and allow you to do some of this automatic generation stuff. So you can actually pull in all of your documentation. All of your documentation is coming directly from your code. This is all auto-generated. I didn't have to define any of this. This is all based off of what I've written and implemented in my code. So all of this is aligning directly to the code that I've used to define my method, which means if I go and change this to say, let's just return, this is a maybe not a great example. Let's, instead of doing that, let's add another method, because we can do that. So let's add another GET request. And we will say get temperature. And this is just going to return a temperature object. I am just going to make this up, because the point here again is just to define your API. We're just working on documentation here, so we're not gonna go too deep into how to actually do all of this. So we're just going to return 10, and I don't think that's a good temperature in either sense, but it will work. Temperature. There we go. So this is going to create a new method that's going to just go and get us the temperature. So if we rerun our service quickly, we should now see a second HTTP method pop up inside of our Swagger spec. It is actually showing up. And if it doesn't, then I know why everything isn't working. What have I done? 500. Oh no. Conflicting method. What? That doesn't make sense. I might have done something weird here, because I'm not entirely sure why that's happening either. Okay, interesting. If anybody knows, let me know, because I'm a little bit confused, but that's okay. Let's go and figure this out, because that's not quite what I was hoping for. So what I'm expecting here is, oh, I do have it. Okay, weird. Conflicting method, fractions. Oh, that's why. I didn't give this a different name. So that's not going to happen. Let's do something else. So the reason this is happening, I should talk a little bit about this because that's what we're here for. Is I had mapped this to something that I had overlapped my functions. So let's go and do this and rerun this, and it should work again. But these are going over one another. So in this case, we have the template here. They're the same. They were overlapping. And so we had a resource that was mapped to the same thing because they were both GET requests. So in this case, /weather forecast is what we're invoking, not GET weather forecast. That's just the name that we've given it. And so the end point for this, if I go and just execute this, you can see it's going to a GET method at /weather forecast, not at GET weather forecast. So there's no way for it to map two of those in this case. That's why that was not working. Because I'm going too fast, we're making mistakes, but that's okay. Let's do a put because we can do that. So this will be set temperature. This will be interesting. I hadn't really planned to do this, but we're going to try it anyway. So I'm going to leave all the implementation. Again, this is not the point of this entire session, so we're going to leave that. Instead, I think we can just add an argument here. So let's say temperature. This might not be a great idea, but let's see what happens. Again, we're kind of off of where I had planned on going, but that's okay. So if we run this, if I go and look at my API now and refresh this, now we have two. So we have two different methods that got added, and they're color coded just for convenience. So you have an isolation between your put and your get, and they're both isolated under this weather forecast object because that's the controller that we have. That's the endpoint that you would invoke this at. And so if we invoke that, or we open this up, you can see that there's now a temperature parameter. So we've added a parameter to this put request called temperature, and now we have that just automatically in our API. So it already knows that we need an integer here, and that it's I believe, a required value. So it's inserted into the query. So if we try this out, I can type something in here and send this request, and we should hopefully get our result. So this gets inserted into our query parameter and sent along with our request, and then we get our same response. So this gives us a way to kind of, again, document all this stuff. So as we add more and more methods, these automatically get inserted into all of the code that we're trying to work with. So that is, I guess, generally a quick overview of how to do stuff with Swagger. There is a whole lot more here. Is going to, or this documentation page is going to go through a lot more about how you can expand on this and do a little bit more with this. We're going to kind of go past this though. So what we have is something that generates this JSON file, and that's sort of where we're trying to get to. Because at least in my experience, that's been sort of what I've ended up needing. There is some really interesting things about how it respects data annotations. So if you're saying this is a required parameter, for example, it will require that parameter and make sure that the API knows that this is a required parameter and it needs to submit that. So you can do all of that. And I think that's all we need to talk about here. So let's actually look at how you can actually use this in some of your tooling. So what we're going to do is kind of step through this in a few different ways. So I have Postman and Nightingale, which are two REST API clients that we're going to kind of pull up. And we've created this REST API. It's pretty simple, but it should work. So let's do v1/swagger.json. That looks like this now. So you can see we now have a put method in here that's doing all of that. None of this should have changed, so that's all fine. So let's go and grab this and move this over to Postman. So if I go and import this with a link like this, I should be able to just import this like that. And there we go. Now we have our weather service inside of Postman. So just like any normal REST API, this is now imported directly into our service, and we can invoke things from here. So in this case, I think it might have already pulled in the base URL. So I can just send this request. Nope, I need to give it a base URL. So let me just figure out how to do that. Whatever, we'll plug it in this way. Localhost 7158. There we go. There we go. All right. Weird cert thing because HTTPS, but that's okay. But now we get our response back. So we just imported our API into Postman, so we can now actually work with this. Apologies that I can't make that any bigger. But that gives us a way to kind of send these things. And we can do the same thing through Nightingale if that's a tool that you use. So with that, you would go into here and click import, and then just drag the downloaded version of this file into here, and it should just import it. Apologies for the train. And so now we have this. We have imported our API here. So this gives us a way, if we've built this really complicated service and we just want to test it and run things against it really quickly, we can do that. But we can go even further. What if we want a API to actually, or an SDK that we can actually give out to people and say, hey, if you want to invoke our service, here's how you do it. So there's actually other ways you can do this. You can use the OpenAPI generator to actually generate a library for you, or generate code that can actually interact with your library for you. So we're going to look at that too. So just kind of continuing to add on to this. And so the cool thing with all of this is it's all automatically generated. So typically what I've found is, like, if you have these collections of objects that you may be creating or maybe documenting, they get out of date really fast because you continue working on the thing. You keep adding new features, and they don't always go back and update the docs when that happens. So you end up with things getting out of sync. The cool thing with something automatically generating your documentation for you is that it's automatically done, so that it doesn't get out of sync because it's automatic, and so it's automatically tied to the same code implementation that you're using to actually implement that feature. So they can't desync from one another. And then you can actually just tie this to something, and most things can pull in an OpenAPI spec. And then you can use that for whatever you want. So we pulled it into Postman here, but you can use it however you want. There's plenty of online viewers for these kind of things. Or if you want, you can even start from an OpenAPI spec and re-implement your API around that. That can get a little bit weird, but it is possible to do. So however you would like. We're going to go and look at a code generator though. So this is called the OpenAPI generator. I'm looking specifically at the documentation for the Docker version of this. But if we go and open this up, there's a whole bunch of stuff here. And what this does is take that API spec that we have and generate code for you. So let's say you want to invoke our library from Go, or invoke it from Python, or invoke it from another C# library. This gives you a way to actually generate from that something that you can actually interact with. And this works for anything that's using OpenAPI. And so the cool thing with that is you can just kind of take that and tack it on to whatever it is. So if you have some third-party service that you're trying to interact with and you want to integrate it into your app or something like that, this gives you a way to actually tie directly into that. So we're going to use the Docker version. There is a tool that you can download. Typically, I've seen this done in like a GitHub action or something. So if you are publishing an API, you can tie this into a GitHub action and publish an SDK alongside it, generated from these kind of things. We don't have that, so we're going to just implement it ourselves, because why not? So let's go and do that. Let's take this command line thing. So there's a few things going on here. I'm going to copy this into a document here. We're just going to quickly look at what this is actually doing and then actually run it. So because there's a few things going on here that are kind of interesting. How this works is there is a API tools open generator CLI image that is going to get pulled and actually run your generation for you. And then that gets a few different arguments here. I have word wrap on, that's weird. There we go. So we're going to go and disable word wrap just because. And then what we're doing is we're running this and then giving it the --rm parameter. What that does is removes the image after it's, or the container after it's run. So this is a one-time process. It's going to run this thing in a binary and then return our results. We don't need to keep that around. So the RM is just to clean up after itself and get rid of all of that extra stuff, so it doesn't just sit around on your computer and do nothing. So we're doing that, and then we're mounting our current local volume. So we're mounting our current directory to this local volume. So what that does is allow us to actually publish the results back to our computer. If we don't mount a volume, we're not going to be able to see any of those changes because they're going to be inside of the container, and the container gets removed when it's done. So that will all get cleaned up and disappear afterwards. And then this next bit is the actual image that we're using. So OpenAPI generator is the actual name of the image. So we're just going to pull that image down and run it. And then the other thing is we're invoking generate with all of these fun parameters. So these are actually parameters going into that tool to actually run it. So the first one here is the path to an OpenAPI spec. So in this case, this is going to a sample pet store spec. We don't want to use that. We want to use our own. You'll notice it's just a random URL, so it can go to any online service. So let's plug in ours. Let's go and grab this and plug in our spec. There we go. And we want to generate, I believe it's C# because we're going to be working in C#. And then this out should stay the same. What this is doing is, again, we mapped the local directory of this generator to our current directory. So what that's going to do is mean that that local file is our current directory, and then out/go, in this case, would be where we're publishing this to. So I'm going to publish this to a, let's do generated /out C#. And I tried to save that. I didn't mean to do that. And let's copy this. And I think I don't actually remember the name of the languages to use. So we're going to quickly make sure I have that correct. And then we should be good. Getting started. Language. That's not what I want. Should be good. But I don't remember where the list is. So let's go and try this and see what happens. So we're going to just copy this. This will only work if you have Docker installed, because we're using the Docker version of this. There are options to just grab a binary if you want to do that. And then you don't need to do all of this mapping of your directory. All of that would just go away. Instead, you can just pass in the generate command and go from there. But we're putting this into a container because that way I don't have it locally. So let's go and run this. So I think created that. Let's just go and go up a directory, just so I'm at my root project directory. Here we go. And we're going to run this now. So there we go. Unable to find it locally. So what it's going to go and pull the image for us. This is just going and fetching that image that we said to run. And then it's going to pull that down and run it for us, complete this, generate some code for us, and then output that. So we should hopefully get an error. That's not good. C#, it doesn't seem to. Oh, it doesn't like my parameters? Is this because of that? Let's try. Might have accidentally missed a space, but that's nope. Okay. What's going on here? So we're getting issues with the parameters here. So it doesn't like that we have -I and so forth. Have I done something incorrectly? Let's go up here to this. And just quickly look. I think everything was fine. So these slashes, if you're unfamiliar, these backslashes are used to continue the line. So in a console like this, what we're doing is splitting a command across multiple lines so that we can hopefully fit it onto the screen. That's what that slash is there for. But now we're getting warnings that we have extra stuff. And I'm not sure why. I'm not entirely sure. So when I was testing this was working just fine. So I have messed something up, but I'm not really sure what. If you're curious, the images for this are all located here. So they're out on Docker Hub. So this is the image that we're trying to run. Actually generate this. I guess let's take a quick look at what the error is. The term I is not recognized as the name of commandlet function script file. Is it? Okay, let's get rid of all of the new lines and see if that fixes it, because I'm not certain that that's what I expect. So let's do this and see if we get something. Okay, that's better. Okay, so it's still broken, but that's okay. We've gotten a slightly better result. And I think this is a certs issue. So that's just because we're developing locally. Let's go up here. Unable to read the remote URL. Yeah, a connection refused. Okay, so this is caused by a series of cert issues that we've run into here. So we can actually pull that out by changing this HTTPS to something else. So let's go and do that. And swap out this with our non-HTTP one. There's probably a better way to solve that, but we're going to do this for now, just to get that working. And there we go. Nope, still. Interesting. So we're getting a unsigned something. What is this? Connection refused. Have I done this right? Why is this causing issues? Okay, sorry, I'm apparently lost. Go and try this. That's good. And working. So now we're getting this error that our connection is refused. We're unable to read it. And I'm not sure. Oh, no. I don't know. Let's not go and try to solve this, I guess. I'm sorry. I was under the impression that this was going to work. But apparently I have missed something and I don't have the notes with me to actually solve this. So we are going to skip ahead and not do this. But I guess the important thing is that typically what this would do is output the generation of whatever you've created. So if you've gone and built something cool and gone and generated some API, this would give you a way to actually generate that into an SDK. So the output from this that I'm expecting is going to be code. So we would get a C# output, and then we'd be able to compile that into our SDK, and then provide that off to developers. And so the cool thing with that is then everything is kind of centralized into what you're doing. So I'm sorry I can't get it working. I'm not entirely sure. We will probably revisit this. There's some other tools around this that I'm kind of in the process of learning that I couldn't quite get figured out before this, so that there will probably be a revisit. We'll probably dive into that at that point. Yeah, that's unfortunate. I would encourage you to try this yourself. You probably will have less issues than I'm having right now. I did break a few things on my computer recently, and this might be a cause of some of those. But that's kind of just how this goes. That's a good point. Yeah, it is kind of like a cooking show. Open it up and say, here's what I made before, except I haven't made it before. It's kind of the point of this entire show is we're kind of intending to show you some of the live coding stuff. The downside is something like this is just going to be me on a search engine for 10 minutes. And I don't know if anybody wants to watch that. We only have an hour. So I'm going to skip that and do that offline. I probably will post something about this once I figure it out. But for now, I'm going to leave it. There's more documentation out here on their GitHub page. So if you're interested and want to learn more about this tool and how you can use it, I would check out this. I will post a link to this in the chat so you can go and grab that. Here we go. There we go. So that's a link to this generator tool that if you want to use it, it's available. You can grab it and just go for it. There's lots of different ways. I was hoping to get the Docker version working. It didn't work, but that's okay. There's a lot of other options. If you have Homebrew, so if you're on a Mac, there's an option for you to just grab it that way. That might be probably easier than Docker if that's sort of your build environment. Otherwise, there's a bunch of other options for downloading a jar or downloading something that will just let you run it locally. But it gives you a way to build code. That's sort of that's the cool part, is getting able to build something to interact with your APIs. We have a few more people here now than we did previously. So we're going to quickly talk about why we're talking about this. APIs, when we're talking about microservices especially, but just generally when you're building a larger software system, there tends to be a set of boundaries between different services. Those boundaries are your APIs. And so the cool thing with OpenAPI, with Swagger, is that it gives you those boundaries and it lets you define them in a in a document. So you can actually say, here's the contract, here's what I'm going to give you. And it doesn't matter if my implementation behind the scenes changes, here's what everything is going to be. And you can use that as sort of your way of defining a barrier between these different services. The cool thing with having that concrete barrier is it means that unless you need to change something, you need to add a new return type or a new argument to your thing, it doesn't matter. It's not going to impact these other services. You might be publishing maybe an extra thing, or maybe the algorithm defining how you get those things changes, or maybe your database behind the scenes changes. But as long as the overall contract doesn't change, that doesn't impact you. So everybody else is fine. And so this gives you kind of a nice way to say, here's how you can interact with us. Don't worry about anything else. It's fine. And it's a way for you to actually kind of interact with these tools. So we've already gone and generated a Postman spec, so we can actually interact with Postman and pull in some Postman stuff. So our API just gets pulled directly into Postman, and we can just start interacting with it from there. We also have this tool. I'm getting lost. There we go. So we've generated a JSON file that kind of defines our API. We also have a UI. So this is just kind of generated for you as part of using Swagger inside of .NET. This service is going to work for other things too. So if you see this, this doesn't necessarily mean that it's a ASP.NET site. This just means that it's using Swagger. This is a pretty default template across the board. So that if you're building your services in Java or Python, you can get something very similar to this and use it in your own APIs. And so what this lets us do is grab our service, look at what's going to come back. So in this case, we have a template response that's going to say, we're expecting to get a 200 response back. And that's going to be in an array with a series of dates, some temperatures, and a summary of what that is. And so we can actually go and send out a request here. So if I hit execute there and send the request, you can see here's how you would duplicate that if you wanted to run a curl request to actually send that. Here's how you do that. But you can also see here's the request URL that we actually went out and hit. So we went out and we sent a GET request to our weather forecast API and got a response back. And here's the response. You can even see what's coming back. In this case, the server is Kestrel, which is .NET. And you can see when it came back, all the headers. And that's sort of the magic of all of this, is all of this kind of comes for free. So your default developer environment, typically you're working in .NET, is going to include this. The way you include it is going into your program and adding the add Swagger gen service. So you're actually saying, yes, generate these Swagger stuff, and then also selecting which parts to use. So in this case, we're using Swagger, which is going to give us all of the JSON files and stuff. And we're also enabling the UI, which is what I was just using. So depending on how you want to interact with your service, you can do that. You could also enable this outside of development mode if you want. If there's like a developer portal that you need, this is a way you can do that. The Swagger spec that I've been showing can be themed if you want to do it that way. So if you just want a really quick developer portal that lets people send API requests to you, that could be a way to do it. There might be reasons you don't want to do that, but that is an option. So that's quickly covering everything that we've kind of gone through so far. Let's take a quick look at some more of the fun stuff that you can do. Because the automatic generation didn't work, we're going to pivot a little bit away from that and talk a little bit more about some of the other options. So far, and for the rest of this video probably, we've been talking about Swashbuckle, which is what's being actually used to do all of this. So those API endpoints I said that add Swagger service, that's part of Swashbuckle. You can see in our CS project file, we already have that reference there. This is just going to be there if you do a web API. If you're going to turn off Swagger, you can get rid of this. This doesn't need to exist there. Or if you're going to use the other option, which is nswag, you could also pull that out and swap in the other dependency. That's what that dependency is there for, is giving you the Swagger generation stuff. So you don't need that. You can swap it out. So let's see what else. There's also some response codes that are being sent back, so you can actually define what those are. And what else? This is the customizing UI stuff that I briefly talked about. You can actually just provide a custom CSS file to change this UI so it looks a little bit less like this. If that's something that you're trying to do, if you're trying to send out a developer portal or something like that, that's a way for you to do it. Typically, I've seen it left like this because mostly, at least the services that I've worked on, have been internal things. So this has been a tool for developers to use internally to kind of interact with each other's services. And it's just a really handy way to get this for free. where you don't need to go and spend a lot of engineering time documenting and building this service to actually communicate with everything. And that's sort of the magic here. Is it's not something where you need to just go and grab a bunch of engineering time to go and document your entire API and write up this developer tool to do all of this. Instead, you can just generate it, and it just appears. And so that's kind of the cool part. Because typically, I kind of mentioned this at the beginning, but typically I've seen whenever you kind of set aside time to build this homebrewed developer tool, what ends up happening is that developer tool gets out of date and then slowly desyncs from current production. So if we had defined all of this in the course of this video alone, we've actually slightly changed our GET request, and we've completely added a put request. So if we had tried to do that, we would need to go back and try to update all of our documentation. We need to add this to our tool. And typically that doesn't happen. Maybe it should, but just because of time restraints and other reasons, it's not common for tools to kind of stay in sync. And if there's multiple things that need to exist in multiple places and kind of match one another, it's really hard to just make sure that that's actually happening, because then everybody that's code reviewing and everybody that's involved in changes there needs to know that that needs to happen. And that's just really organizationally complicated. So the cool thing with this is it gets rid of that. All of your documentation for your API is centralized in the implementation of your API. So in this case, that means that all of what we're seeing right now, all of that UI is defined in here, is actually defined inside of our controller for this class. So we have our put request here with that temperature input. We have our GET request doing the exact same thing, just as a GET request. And we have all of the other bits that we don't really care about for this particular thing. This gives us all of the information we need to generate those abilities to actually interact with this website. Because we're saying where the request should be routed to. We're giving it the type of request that we're intending to send, whether it's a GET, a post, a put, a delete, and some of the other ones that I don't remember because apparently there's more than 4. But you can send those different things and define it here and then have it get rolled out to everybody. So that's the cool thing. Let's quickly add another controller here. So I'm just going to copy this weather forecast and lose which one is which. Let's do temperature controller. There we go. So sticking with the weather theme, we're going to create something that changes the temperature, I guess. And this is going to be simplified, I think. We're going to just return a float. So this returns not like that. That's not how this works. We're going to return 10. Sure. Again, implementation can change. That's the cool thing with this. All we've said is that this is going to return a float. So whether I say it's going to return 10 or not, the actual return type doesn't change there. So we can actually go and change that later and not impact our contract. So not impact all the other services that needed to depend on it. We can do this, give the other dependencies in our chain something to rely on, something that says, here's what this response is going to look like. This is what you need to match. This is what you should expect. Build around this. And then we can implement it. We don't need to do it all beforehand. And so this kind of gives you a nice way to kind of go at this incrementally. So you can actually deliver your entire architecture and how everything should communicate, what those communication requests should look like, set up all the communication, generate everything, and then implement everything around that, and kind of do it incrementally. And then this, let's just get rid of our put request for now, because that's not really why we're doing this. And then we'll just say this is get temperature. There we go. And that's not the right name. So let's help this out. And we can keep the logger injection, I think. let's swap that out. And I think everything else should be good. So let's go and run this now. And now we should hopefully, if I've done this right, have both of these. So we should now have a series of different endpoints that are kind of isolated this way. So if I jump over here to my service and refresh this, hopefully, there we go. All right, so now we have temperature, which is its own controller isolated off into itself. And we have our weather forecast, which is another separate thing. So this gives you a way to separate these two different things. The other thing that can happen is you might want like an API Explorer, something where you can actually go and explore all the APIs, maybe in your organization or something like that. There's a way to do that too up here. I just have one because that's all that's there. But you can actually have these definitions up in the top. It'll give you a way to actually select these different specs and swap through them. In this case, we're just using the default generator attached to our service, so that's less useful. But if you're trying to build something where you can actually go and navigate and find and discover these APIs, this gives you a way to do that in a relatively integrated way. And then we can just go and figure out what this is going to do. So in this case, the example value is just a 0 because we said it's going to return a float. It doesn't know what type of float to expect. So it's just going to say the example value is just a 0. So you should expect to be able to handle 0. Even though we're returning 10, it didn't run our API. It doesn't know that. It just knows that it needs to be a float. So it's just the default float value. We can go and actually define what this is. So if we have some time, I will go and quickly do that. But quickly, let's just execute this. And so we get a 10 from our API. So we just ran this, got our 10 back, and ran our temperature. So that's how this works. And so you can just keep doing this. You can keep adding more and more and expanding this, and it just keeps going with that. And I'm not needing to do anything other than implement and do my work. So let's figure out how to change that definition so that we can say, you should actually expect this to be something else. So I believe we can do a response type up here. Yeah, here we go. So let's just copy this. And so you can actually add a sample response here. So let's go into our temperature and do that. Like, all right. So sample request. Is that what I want? That's a sample request. We're just going to go with this because, again, the point here is not necessarily to properly document this sample API. It's to show you what this can do. So let's do this. And I believe this is going to add actually a sample in place of what we were expecting, because this is a post. So what we're actually doing is saying, when you're posting a new to-do item in this case, you would give it an ID, a name, and is complete. And you would have these values assigned to it. So we go and look back at our UI. Hopefully our temperature looks a little bit different. And that doesn't show up either. I'm wondering if I have missed something, because I'm expecting this to generate differently, and it's not quite doing what I think. Because we should have had documentation for these other requests as well, and that didn't show up either. So I might be missing something. I will post an update once I figure that out, but I don't actually know. Yeah, this is, I guess, sort of where I wanted to get. We did briefly talk about the code generator. That was sort of the cool part. And unfortunately, I ran into some issues there. Highly recommend checking that out. If you're using the Docker image, you don't need to install anything. It's just going to be a Docker file that's going to run and then delete itself. And then you can just clean up the image afterwards if that's something you care about. So that gives you a way to kind of just quickly generate code for yourself. So if you're trying to write an app or use something else where you can interact directly with a service, that gives you a really nice way to do that, because now your services can just communicate together. You have the client generated for you. And so you don't need to go and like implement the entire JSON data structure of all of your responses in order to handle those requests. It's just done for you based off of the code gen process here, based off of our JSON file. And that's a lot nicer than going and like trying to implement the schema. We just have this one for field, I guess, parameter or class. Typically APIs are a little bit more complicated. There's a lot more going on there, and then you have to implement all of that. This can automate that for you, which can make the entire thing a lot more pleasant. So hopefully that's helpful. I will try to post an update, and we will probably revisit this. There's a few other tools that I kind of wanted to do. There's some extra tools around .NET specifically to make this even nicer that I'm in the process of going through. We did demonstrate sort of some of the .NET stuff here. If you are working in something else, maybe you're working in Spring or Flask with Python, those also support OpenAPI. What that means is you can just go and take these and start generating them. The code generator can generate code for APIs in any of those languages, or you can generate a Swagger spec from those languages. So it all kind of talks together. And so if you have a language that is being developed or a program that's being developed across multiple different applications, or you're developing something that needs to work on certain platforms in a specific language, this gives you a way to actually do that, or provide APIs that support developers doing whatever it is they need to do. If you need to give somebody an API, this is a good way to do it. So hopefully that's helpful and you can use it in your projects. If you do give this a shot, let me know. If you're looking to kind of get started and find some more documentation, you can go to aka.ms/.NET OpenAPI, and that will take you to this page to kind of get you an overview, and you can read over all the different things. Other than that, there was a survey link posted in the chat. We'd really appreciate it, or at least I'd really appreciate it if you would fill that out. We're constantly looking for feedback and trying to improve these shows. So if there's ways that we can do better or help you more, let us know. That's a great place to do it. Otherwise, if you have specific feedback, feel free to reach out to me directly. Happy to chat. So thanks everyone for watching, and I will see you on Thursday when we talk about Kubernetes. So.
Thanks a lot, Sam. We appreciate it. Everyone, as just Sam mentioned, we just dropped the link to the survey in the chat. Please use the AKA link if you have time, and use the code 16794, and let us know how this event went. Other than that, thanks all for joining.
Thanks, everyone.